Before we get into lesson 4, writing expressions, we are going to do a little activity to introduce the concept because this can be a tricky thing to do. It's the first time we're really writing algebraic expressions before we get into the equations unit. So we have a chart here, and this cheat sheet is also in your resource packet, so we're going to practice making it, and then you will have reference to it there, as well as you can keep this sheet to reference, okay? It is broken down into the different words. So first, we're going to look at those that are subtraction words. So the key word, less than, I'm going to highlight in here, okay? The number that is given to me in the problem, I'm going to circle. And then our unknown, I'm going to underline. So our unknown here, a number, is what I'm underlining. These 3 steps are what we're going to do for every single example here, as well as for the rest of the year. So anytime that we're annotating our work, if we have keywords, we're highlighting. If it's an unknown, we're underlining. And if it's a numerical value that's key and important to us, we are circling that. So subtraction is important because the order with subtraction matters. I would say, and if you want to put a star next to this or something, this tends to be the one that most people get wrong. If I said you are 3 years less than me, in your age, you're not going to do 3 minus my age. You're going to do my age minus 3. So anytime we see less than, more than, younger than, we're taking it after. So when I see 3 less than, I am subtracting 3 from something. What am I subtracting it from? Our unknown number. And we're going to use x as our variable for all of these. Later on in the actual lesson, next week, we are going to, the lesson tomorrow, we are going to use possibly some different variables, but for today, we're only going to use x. So let's look at the next example. The difference is our keywords. The difference between a number and 8. So I'm going to circle my number that's given to me. I'm going to highlight the keyword, which we already know is difference. And our unknown here, we don't know what this number is. In this instance, when it just says difference, we go in the order that it is given. So it starts with our unknown number x. Difference means subtraction. What is it, the difference between x and 8? So x minus 8. Next up, we have decreased by. So going through my process, I'm going to circle any numbers given to me. So I see the number 2. I'm going to highlight the key word. So decreased by, word or phrase in this instance. And then underline our unknown. So again, a number is our unknown. So just like difference, decreased by is just going in the order that it is given. So we start with our unknown number x. We are decreasing it by, so we are subtracting 2. And last example here, I'm going to star this one again because it's just like the first one. The order matters. Younger than. And here's like an actual real world scenario. Alex is 5 years younger than Tom. So I'm circling 5. I'm highlighting the keyword that we've already identified here is younger than. And our unknown. So sometimes people get tripped up here because they're like, well, we don't know Alex and we don't know Tom. When we get to equations, we might use both variables, but in this instance, we are comparing Alex to Tom. So we have to know Tom in order to figure out Alex. So our unknown here is Tom. As I said in the actual lesson, we might start using different variables. We're still just going to use x. So anytime we see less than, younger than, it goes after. So as soon as I see 5 years younger than, I am subtracting 5 from our unknown variable. Because if I say he's 5 years younger than Tom, we're not going to do 5 minus Tom's age. We're going to take Tom's age and take away 5. Next up, let's look at addition examples. So same process, I'm gonna circle the numbers, highlight the key words or phrases, underline the unknown. So 9 more than a number. 9 is our number. Our key word or phrase is more than. Our unknown is a number. Technically with addition, order doesn't matter. 2 plus 3 is the same thing as 3 plus 2. Versus when we did subtraction, we're saying order matters because 2 minus 3 is not the same as 3 minus 2. So addition, technically it can be flipped around, but we should still be practicing putting it in the proper way. I'm gonna put a star next to this one because it's similar to less than, younger than, more than. Anytime I see that, it is going after. So 9 more than means I'm adding 9 to something. What am I adding it to? Our unknown number x. Next keyword, the word and can mean addition. So circling my number, 4 and a number, so circling 4. Highlighting the keyword here, and underlining our unknown, a number. So 4 and a number. In this case, I can just go in the order that it's given. We have 4 plus we have our unknown number x. But that would be the same thing as x plus 4. Next keyword, plus. Well, we know plus means addition because it's the same thing, right? We use a plus sign for an addition sign. So I'm going through and circling my numbers. A number plus 5. Keyword is plus. Our unknown is a number. So just like and, I'm going in the order that it was given. A number, so we have a number, plus we are adding 5. And then last one, increased by. So a number increased by 12. Circling my number 12, highlighting the key phrase, increased by, underlining our unknown, a number. Just like and, just like plus, just like decreased by, increased by is just going in the order it's given. So we're given our unknown number first, we're increasing it by, so we're adding 12. Now let's look at multiplication. As a reminder, when we are writing multiplication, technically 7 dot x means multiplication. 7 parentheses x technically means multiplication, but the most proper way to write things is with a number right next to the variable. We'll technically accept this. We want you to get in the habit of writing it the most algebraically. If you write it as 7 times x, we are not going to accept that. That is really confusing. Which one's an x? Which one's a multiplication? We don't want you to use that. So let's look at these examples. First keyword is times. So we have 7 times a number. So circling our number 7, highlighting our keyword times, underlining a number. 7 times a number, we're going just in the order that it's given. So 7 times a number, x is just 7x. Next keyword, and a lot of times people forget what this means. Product means multiplication, okay? And on the back sheet here, you'll be able to reference as well. It has them kind of broken down into the keywords that you can reference. But here, we've got the product of 11 and a number. So I'm circling 11. I'm highlighting our keyword, which is product. I'm underlining our unknown, which is a number. So the product of 11 and that number, we're doing 11 times our unknown number x. We're just writing that as 11x. Next keyword, of. I'm going to put a star next to this. Of means a lot of times we'll see of as in fractions of, 2/3 of, 4/5 of. Obviously, of is a very common word. So really where you're seeing that is when you have actual fractions in the problem. So if I look here, I have a fractional number, 3/4 of our keyword, a number. So 3/4 of a number, 3/4 comes first of our unknown number, x. So just 3/4 x. Twice. This one can be tricky because guess what? Twice kind of means two things. I'm going to circle it because twice is telling me the number 2. But I'm also going to highlight it because it is also telling me the operation of multiplication. Then our unknown. Jane is twice as old as Ellen. Just like that example up here with Alex and Tom, we have 2 names. So we kind of have 2 unknowns, but Jane is being related to Ellen, so Ellen is our unknown. We need to know what Ellen is in order to know Jane. So Jane is 2 times as old as Ellen, so she's 2 times our unknown x. Per or and, you'll see either of those. Per means multiplication. That is one we see a lot as well. So it costs $15 per textbook. I'm circling my number. I'm highlighting my keyword. I'm underlining the unknown. We don't know how many textbooks. So it's $15 times each textbook. It's 15x. 15 times however many textbooks I have. And for every is very similar. Per and an, for every and an, they're very similar. So James earns, we have both examples here, $10 for every hour worked. Or James earns $10 an hour. For every and they mean the same thing. And our unknown in both of these is hour. So it's $10 times every hour, 10 times our unknown x. All right, last up we have division examples. Quotient, the quotient of a number and 13. So our number is 13. Quotient is a tricky word, but if you can realize that that is division, that's going to help you out. So quotient means division, and our unknown is a number. So it's the quotient of a number and 13. Just like we want to get away from using x for multiplication, we want to get away from using division. So I want to get away from doing like x divided by 12, okay? I want to get away from that. So we can use division algebraically by using a fraction bar. And then I'm just putting in the order it's given. The quotient of a number, x, and 13. Get away from using the division sign. Next up, splitting. A number split in 2. So our keyword is split. Our unknown is a number. So we're going in the order of our unknown x divided by 2. I'm writing it as a fraction. X over 2. And last up, into, you're breaking it into parts. So a number broken into 2 parts. So into, broken might help you kind of key into the fact that it's division. And then our unknown is a number. So we're going in the order of our unknown number, x, division with the fraction bar, dividing by 2. So this cheat sheet is in your resource packet, but this is really nice because it's all color-coded, which might be easier, and it's big to visualize. And it also has this half sheet on the back here, which is in your resource packet as well. But we should hold on to this. You can use this unit to reference. Anytime you're getting a similar problem, you can see how the expression is set